to be in orbit.
I see the flying car industry as game changing when it comes to not only future warfare, but future military operations. Just as important, humanitarian relief operations, hurricane support, all the things that we do defense of the homeland. If you start thinking about these devices as nodes in a network, it fundamentally changes the game.
Agility Prime is a program with a vision of world impact. By partnering today with stakeholders across industries and agencies, we can set up the United States for this aerospace phenomenon. Potential outcomes are rewarding and transformative with both military and commercial applications.
I want to offer my congratulations to Dr. Roper and his team for achieving this revolutionary rapid contracting and prototyping method to bring industry and DoD together to develop this new exciting technology with both military and civilian applications. This technology will have great benefit to the needs that we have in Alaska and the Arctic, where conventional aircraft, vehicles, and vessels oftentimes can't operate.
Agility Prime is part of our Defense Department's long history of turning futuristic ideas into reality. I'm proud that the federal government is investing in revolutionary ideas. Agility Prime is leading the way.
This launch of Agility Prime is so exciting. This technology has the potential to make vertical flight more affordable and more widely available. And with the encouragement of the U.S. Air Force and the entire federal government, American companies employing American workers can gain a head start and win a fair share of this lucrative market. eVTOLs have the same agile, vertical takeoff and landing capability as helicopters, but are quieter and should cost much less to operate because of their electric motors.
We are becoming a trusted innovation partner in commercial tech. I could not be prouder of this initiative. I could not be prouder of this team. And I am excited to see how quickly we can go to help commercialize this market for our nation so that our warfighters have options they don't have today, and our nation has an economic advantage far into the future. Innovation is a battlefield, and Agility Prime is just one way we're going to win it.
Agility Prime seeks to ensure a global advantage in advanced logistics technology. Agility Prime can reduce the risk of adversary commercial dominance, resulting in military disadvantage. As the United States Air Force looks at generating combat power away from runways, those distributed logistics aircraft must be runway independent. This new transformative capability is a promising opportunity to conduct that mission in an affordable and a scalable manner.
Today, we gather for Agility Prime to drive transportation innovation, lower barriers to entry, and expand our partnerships.
We see a time when automation technologies make the requirements on the pilot much less. And we see flying as being accessible to a much wider range of people.
It is truly a great credit to Agility Prime. They could put on this virtual event with so many hometowns of the United States represented. You know, industrial base is not really about just what a country can make. More than that, it's about the people who dream up what to make. And then, of course, those people who make it.
Good afternoon, and thanks for joining us on this Friday before a long weekend. Really appreciate everyone taking the time here. We've got a fantastic lineup for this afternoon with some really exciting guests here. We'll go through that lineup here in just a little bit, but just wanted to talk through a couple of things that we have ongoing. We've got several of our companies who are just now getting awards through this air race to certification. Some of them will be starting work soon, doing wind tunnel testing. We've got some of our test professionals that are going out and providing direct consulting support for some of the test programs that are out there. We've been providing some opportunities for those companies in this air race to certification to actually get into some of our simulators and be able to do some of their training. We've got simulators that are being built right now. Looking forward to those being delivered so that we can start to think about training our own air crew, think about testing some of the different concepts of operation. We do have as well those STTRs looking to fantastic different technologies that were identified out there by all of you who applied those 335 submissions for the small business technology transition efforts with universities, research institutions, and the small businesses that are out there. As well as we've got several of the larger aerospace defense corporations who are bringing their projects in. So exciting time, continued progress on this, and all that progress thanks to the partner companies that are out there, thanks to our fantastic airmen that are out there helping to drive this, different concepts coming together, thinking about different use cases that are there, starting to put some numbers to those use cases as we're doing some of the business case analytics of what does it look like as we start to fly orbs in the Air Force, and still pressing forward on that 2023 fielding with great support that we're getting from leadership. So today we're going to dig in and talk in a little bit more detail about one part of that testing process. We have a couple of folks associated with our Air Force Operational Test and Evaluation Center, Captain Oust and Ms. Kreider, talking about the STPA process and theory and how we believe that's going to lead to a much more robust and a faster approach to our flight testing that we're doing out there as we quickly bring these in. Next after that, we've got Jeff DeCoo from the Autonomy Institute. Clearly, autonomy is a key piece of the long-term success in this industry and with this technology. So Jeff will be talking about that supporting intelligent infrastructure that's necessary, talking about some potential opportunities that we have in the near term on partnering with those folks that are interested in building out that autonomous infrastructure and all of the different pieces that are associated with that, the sub-technologies that are there, many of those technologies being addressed through that STTR. So thanks for joining us, Jeff. Looking forward to seeing that. We also have Teaching Carbon America Incorporated. We've got Alfonso Lopez looking at different materials, composite materials that are out there. Clearly, as we start to build this at scale, it's going to be essential to have the materials that are necessary to do that, maintaining the appropriate level of scale, speed, as well as obviously the safety associated with that. So Alfonso, thanks for joining us here. After that, we've got Maglio Incorporated with Ted Thayer, the general manager there, with a series of different part subsystems, some of the consulting associated with that. Looking forward to seeing that. We've got One Sky with Chris Cusara. I apologize, Chris. Looking at the different opportunities associated with the Grand Challenge that they're doing, the urban traffic management, some of the things that they've done with the small UAS industry, really some impressive work that's happening right now in remote ID, and what that's going to do to create more opportunity across this entire advanced air mobility. And then last, but certainly not least, we've got real-time innovations with Chip Downing here, looking at different avionics, airworthiness, some of the really important parts of the certification of the processes, the DO-178 processes, there are different software frameworks as we move forward and think about what it looks like with the advanced software that's needed. So with that, Sterling, I'm going to hand it over to you to walk us through this tour of our ecosystem. But before we do that, I'm going to hand it over to our AFWERX team as they talk about this new approach to testing that we feel is going to have so much promise in our speed and resiliency of our test system.
Yeah, sure. Thanks, Colonel Diller. We're actually going to go to AFWERX guys at the end here. They got pulled into a meeting, so they're going to be joining us at about 3 o'clock. But we'll start off with Mr. Jeff DeCou on autonomy. Jeff, over to you.
I appreciate it. I look forward to that discussion because it sounds like it's going to be a good one. First of all, Colonel Diller, thank you very much for the time and the opportunity to speak. Thank you for the passion and the drive that you're showing with AFWERX and the Agility Prime initiatives. And probably the biggest thanks has to go to your wife that's probably trying to keep up with your schedule and all the activities that you've been involved with. I think that video really highlights one key thing that I think all of us understand, but a lot of times it's overlooked, is in the video we just watched. At the very beginning, you had the General Goldfein say, we need to picture these orbs as being nodes in a network. So the question you have to ask yourself, what network is that? Because that network does not currently exist. And that network has to be a resilient one, and it has to be one that really has many, many more features and functions than we're used to coming from the FAA standpoint. So what I was going to do is just hit a couple slides talking about just kind of setting context of who the Autonomy Institute is. So even though, as reflected, it says Autonomy Institute, we really reflect that autonomy is the moonshot, and the impacts and benefits to society. We will see a decade worth of impact and value extracted out of these innovations before we, quote, necessarily see autonomy being deployed within the public sector. The initiative of Path to Commerce, there's a tagline for the Autonomy Institute, is a path to commerce. And to reflect what is the Autonomy Institute, we had Admiral Inman, which was the founder of MCC and Sematech, kind of summarize in that it's the Sematech for autonomy. And once again, autonomy is a long-term shot, and there's many things that have to be addressed before then. And we're a 501c focus on Path to Commerce. Our focus is how can we align industry along with government and academia to accelerate those efforts. And that means we have to do far more of this collaboration, and we actually have to have facilities that allow 24/7 testing. So if we believe in orbs, we believe that there are going to be networks, or nodes in a network, then we actually have to have the appropriate facilities that support that advanced testing. So we kind of summarize the Institute in three major drives that we have. One is establishing labs at leading universities, research firms, and other places like bases across the U.S. Establishing larger corridors within urban environments like the city of Austin and Dallas and Pittsburgh are a couple that we're in discussions with right now, and eventually leading to an orchestrated environment where, if we really do believe in this future, and we really do believe that we're going to see tens of thousands of things either flying or coordinating on the ground together, we need to understand, just like the FAA did in the early days, is we have to have a systems environment or operation center that these players participate in. And that means new technology that's down on the ground. And by having these labs, we can accelerate testing, and will eventually lead into where we have larger areas within cities, and that will lead into the critical piece that all of us are dependent on, which is the policy and regulation that will support it, embrace it, and where society will actually enjoy the benefits of all these new technologies. So I'll leave it at this slide because it really helps understand the magnitude of the challenge. So this is not easy. I mean, it's challenging enough to get a sophisticated flying vehicle, an orb, up into the sky, and for it to be reliable and resilient and certified. It's even a larger challenge if we don't have the appropriate highways and byways defined that allows these things to be deployed within a city or in even a suburban environment or even a rural environment. There's critical technology that has to be adopted to allow these things to exist. And our mission is to, as fast as possible, get a number of these 24/7 labs to really scale test and allow a lot more collaboration to take place between industry partners and working with academia and government. And we're looking forward to the initiatives of AFWERX and Agility Prime and the programs that you have, because they happen to be really the leading agency that's really driving innovation forward that we see from the DoD. So I'll stop there for any questions that people may have.
Yeah, for sure, Jeff. Just for me personally, I haven't seen your talk before, so I'm just a little curious. What is the benefit of having these pins kind of distributed across the cities instead of using something like a satellite network or a radar, wider area network?
Great question. And it all comes down to what scale are you operating at. So if you're going to be operating at a higher altitude, let's say 1,500 feet or above, which is predominantly where these systems have existed up until now, the FAA has very resilient systems. They have radars and lidars, radars and transponders and beacons, and they have antennas, and they have space-based GPS, ground-based, GNSS. But if you go down into a city and you start dealing with, the key is data and connectivity to actually be communicating these, that infrastructure does not exist. It's not like you can just call up AT&T and say, hey, I'm going to put a SIM card in my device, and now you can have a resilient network connected to it. There is no resilient and volume data traffic that exists right now within cities or even suburban environments that can do even the simple things like just have drone ID or orb ID active within the industry. So the good thing is, to lay everybody's concerns aside, the billions of dollars it's going to take to build this, those dollars already exist. We have now 4 infrastructure investors already allocating billions of dollars for building this out. And you'll say, why would they spend all that money? It's because they will go to cities and they will go to states and they will license or get a concession for 30 years for the ground easements for that equipment to be installed. And there's already buyers that want to be inside the pins. Like all the carriers want to deploy a more dense network for their 5G. You have the edge compute that want to actually put compute actually on the sidewalk to do things like advanced retailing and unfortunately advertising. And then you also have ITS, so Intelligent Transportation Systems from Siemens and Honeywell and CAPS, all want to get radars and lidars and other sophisticated sensors on the street corner. So there's already the dollars, and there's already the use cases, and there's definitely the need, because without situational awareness down in the urban valleys, we're not going to see any of these technologies deployed at any scale outside of a POC.
Yeah, for sure, Jeff. Sorry, Nate, did you have a question?
Yeah, sure. No, thanks for that, Jeff. I think the work that you and your team have done, kind of just bringing awareness of the work that's needed here, I think is super helpful. Can you give just are there examples where, there's meaningful work happening in this vein right now? And then just talk a little bit about the scale. Is this something that has to, we go city by city? Is this, where do you see, this things providing some good path for the future there for folks to understand, really the value proposition here? What savings? What's the business case for this? And where are we seeing this today? Maybe in some.
Yeah, perfect. And yeah, there's 2 main paths. So the main path that we talk about is the labs, getting scaled testing to allow all the systems that NASA, FAA, and MITRE have been identifying that need to be tested and scaled, and petabytes of data to be captured to validate. That's the main path we're trying to accelerate. But the path of the pins is happening independent of this, because the pins, they're being deployed independent of anything autonomous or anything that we care about. Is the pins are a critical piece of infrastructure that has to be deployed because the technology is already coming. So if you're not aware that, this is a good slide to kind of show, And if you're in a city, most likely you're starting to see things like this happening across the city, where a lot of antennas and whether it be cameras or lidars or other type of radars are being deployed by all kinds of different companies. That has to be solved through some infrastructure, and that's going to be densified with the additional 5G and the edge computing and the ITS technology. So those are being handled by the P3, public-private partnerships. So the funding for that, $150 million for, let's say, the scale of City of Austin, that is a process that's going forward to secure how this technology will be moving into the city and be supported for the community in that area.
Sure, that's great, Jeff. Great to see you guys are putting in some great work to move this along. Appreciate you coming on. Always interesting to hear from you. And now we're going to switch over to Mr. Alfonso Lopez from Tejan Carbon. Mr. Lopez, over to you.
Hi, thank you very much. Can you hear me?
Yes, sir. Got you loud and clear.
Great. Let me share my presentation. Get that going here. Okay, does that look good?
Yes, sir.
Okay, well, thank you very much, Colonel Diller, AFWERX and Agility Prime, for inviting us to present Tejan. I'd like to start off on a personal note, I think, and a clear case for orbs. August 17th, I and my family, we had to evacuate because of the Ohlone complex fires in Sunol. And the picture you see on the left there is actually one my son took when he was mountain biking. And this was a nascent fire, and we reported it. Unfortunately, because of the rugged terrain, firefighters, they couldn't get up there by foot. It took about 48 hours to call in air support and drop fire retardant. And then we were able to, thankfully get back to our homes on the 18th. But that's a very, very clear case for orbs, and talking about autonomy. If an orb could have gotten up there and just dropped fire retardant on that nascent fire, it would have saved a lot. In addition, we had one pilot firefighter that lost his life because of that. Not this fire, but elsewhere. And so I think orbs there are a clear case for this. So with that, thank you. Keep the passion. And for me personally, if there's orbs makers that are tackling this, please call me. I would be personally very interested to work with you and support with Tejan materials wherever possible. Okay, so Tejan is a global company. Tejan Carbon America is where I work. They have a lot of business divisions. So I'm just going to cover the composite material side of things, and that's Tejan Carbon America. Renegade Materials, high performance, high temperature stuff. Tejan Aramid, a lot of impact, abrasion, and fire resistance and safety applications. And Continental Structural Plastics, which one day may be bridging the divide between aerospace and very high rate components. Okay, so just a quick overview. If you're taking screenshots, this is a good one. I'm not going to go into detail, but this has websites where you can get that kind of stuff. I'm mainly going to be talking on Tejan Carbon. I'm not going to be covering OPF. That's for carbon stuff, not that applicable. And then I'll be touching on Tejan Aramid, Renegade, and Continental. DuPont has done a really good job on marketing and making Kevlar synonymous with Aramid, but we call ours Tauron, and it does an exceptional job. Renegade, they are very good and work with the military quite a bit. They're a recent addition just last year to the Tejan group. And we're hoping in the future, they're going to grow, get integrated, and we're going to have more material options and technology transfer to them from our Japanese and German research offices. And finally, Continental Structural, excitement about that. They're, end-to-end turnkey for design, material solutions, and fabrication for automotive and transport, which we're talking about today in the vision for orbs. Okay, so a quick overview then for carbon materials. We're very well known for carbon fiber. Not too many OEMs use carbon fiber from a spool though. But I think a direct example for orbs is high pressure tanks. since we're, we might be talking about hydrogen or natural gas. And that example on the bottom was a collaboration study with IACME and Oak Ridge National Labs for in situ characterization of health monitoring and performance. Going to the upper right, something I'm very excited about and I work on a lot is non-crimp fabrics. That's 090 biaxial you see on the upper left. And the corresponding example, which we're proud of, is the A320neo spoiler. That's a RTM non-crimp fabric part made totally by automation, and it's replacing a legacy aluminum part and saving weight and cost over the lifetime of it. Going down, thermoplastics have certainly gotten a lot of attention, and on the left hand is just an image of thermoplastic PEEK tape that Teijin supplies for like AFP. The corresponding example there is also Airbus clip on the A350X. There are hundreds of these. That's made with a consolidated laminate and stamp formed. And finally, on the bottom right is, I'm not going to belabor or show a lot about this, but it's a pretty neat carbon fiber automated process to make drop-in preforms. It's essentially kind of like a glass spray-up technique using 20-millimeter long carbon fibers, in which a robot places it, forms it, and then it's ready to go for RTM. Okay, I'm going to spend a little bit of time on this because this is my passion. In my previous life, I was an R&D engineer working on mainly out-of-autoclave stuff. And NCF, I think, is a very good option for orb makers that are going from design and thinking about high rate as well, just because of its qualities. You're getting more than 2 layers in one ply when you're laying it down, from 2 to 4 for us. It has excellent permeability and infusion qualities. The example on the upper right there is a 144 ply slab of material that we infused in about 20 minutes. There in the middle is a result. We got pretty low void volumes and about 55% fiber volume fraction. And what that allows is, you get properties, but you can also integrate different thickness structures. And the one on the bottom left there is a one-shot infused skin and I-beam to form a box beam. And we're resin agnostic. You can use whatever low viscosity resin of your choice that you would like. This example here was with a resin that had about 20 to 30 centipoise during the process time. I'm not going to belabor this slide. David Leach from ATC did a great job last week in explaining all the benefits of thermoplastics. I'm only going to make a couple points here and say that Teijin's been developing these materials for about 15 years. The woven fabric and consolidated laminate with PEEK thermoplastic are currently in a finalized NCAMP qualification. We hope to see those results in the next couple months. And the second thing I would say is, please think of Teijin as a partner to learn how to use these. Most orb makers aren't ready for these. These require, maturity. But what you can do is start to learn and use them so that when you are ready, you know what to expect. And this doesn't get a lot of mention out there, but you can vacuum form these materials and get really good results. And the most you'd need really in specialized equipment is an oven that can go, preferably above 400 degrees C. You do need to spend on things like polyimide film and high temperature sealants, but those are a heck of a way less expensive than continuous compression molding or a steel mold with integrated heaters. And you can start off as easy as a steel plate and just make panels to figure out how this stuff works, and move on to like simple steel forms, L shapes, hat shapes. And if you want to get complicated, get creative. Orb makers out there are definitely that, and think about like refractory ceramics where you just want 3 or 4 parts and you're not too worried about the structural integrity of the mold. And call us. We're creative too. We'd love to help you learn about them. Okay, so here I'm not going to spend a lot of time because I'm not the expert. I just wanted to really give you some good examples of where our sister companies work. As Colonel Diller said, safety is a big issue, and aramid is a big material part of that solution. I'm not going to go through all of these. I'm just going to point out a couple of primary examples that I think were directly translatable to orbs. One is for engine duct containment. Aramid is used for blade outs, in which you want to contain, that blade from rotating and spinning out and causing death or damage. And I have a picture here of the city Airbus, which I believe that's a ducted fan. Those structures might not be a duct, but you're going to certainly need to contain the failure of a blade or rotor on those vehicles. The other one, and I hope that automation's safety doesn't get too angry at me, but they had a really good presentation the first week of the ecosystem, and their chute color scheme immediately reminded me of the supersonic braking chutes used with the Mars Lander rover missions, in which Teijin Aramid has been supplying cord for those chutes. And as well, a few other applications that are applicable for interiors, where you might have wear applications, or again, high pressure vessels where you want to have some sort of covering in case of explosion and shrapnel. Okay, so Renegade, I'm not going to really cover these. I just have these slides on here for when this gets posted, and maybe folks that didn't have a chance to see this can review. They're very good in working with military partners. A couple of examples there are the F-135 Pratt & Whitney engine on the F-35 Joint Strike Fighter, and Passport engine from GE for long-range business jets. Both of those have very high temperature components where polyimides are used. And as well, there is some out-of-autoclave options for that. The only one area that I think might be relevant, and give us a call if you have radomes and antennas that require very low dielectric composites. Renegade, has a solution for that. And finally, one sister company I think I'm very excited to work with in the future is Continental Structural Plastics, because they're already there with regard to high rate manufacturing. And if we think about aerospace, those techniques lend themselves directly. The examples here that I took and could imagine things from are like the truck box. You might think about cargo containers or monocoque structures with integrated ribs and features for attachments. The nice thing about a Cerebo as well, it's a nylon and it's completely recyclable. You can chop it up and compression mold it into a complex part. Battery boxes and enclosures are also a very big one for Continental Structural Plastics. They're well aware and they're experts in the requirements for current EV automobiles. The primary suppliers to Chevy. And finally, something that I'm really excited about is rapid cure prepregs and compression molding for primary structures. That picture on the bottom is just a real spoiler for a sports car, but I could well imagine with the appropriate resin system that could translate into primary parts for rapid fabrication. Last slide then is just another screenshot one. Our contact information, get in touch with us, use this as a soundboard for learning. And if you need anything, just let me know. And again, I'm personally very interested to work with orb makers that are looking at first responder type stuff. And so with that, thank you very much, and I'll turn it over to Sterling.
Yeah, thanks, Alfonso. That was great. Just a question for me, kind of in general, out to the ecosystem. For those folks who are starting up, working on their designs in various areas, what do you think the best pathway for them to start thinking about incorporating composite design when maybe engineering design tools don't have the strengths and design limits that are associated with your products?
Well, I mean, that's a good question. And I think for a lot of early companies, they're looking for stuff that's readily accessible. Teijin works directly with big OEMs, not so much with early startups, but we are changing that, and we are changing our practices to do that for small quantities. I think NCF is a direct material that we do offer that would be applicable and appropriate when you're starting to learn about infusion. I think most orb makers look at fabrics, but NCFs, as I think commercial side demonstrates, really offer a good balance. And they're easy to infuse and work with. You know, they're very robust for that process if you're talking about RTM or infusion.
Yeah, for sure. And then just, is there some kind of database that gives kind of expected strengths for the materials depending on how they're utilized? Or do you guys offer consulting services to designers as they work to design their products?
Yeah, that's an excellent point. You know, orb makers, especially when they're new, don't have money to, you know, spend $1 million with that kind of stuff. There is currently an NCAMP qualification program going on with our NCFs right now. That probably will be done in about 18 months. As well, you know, big OEMs, they have their own databases, but we do work with them. And if you have high enough volume application, we can share costs toward qualifying a material for your application.
For sure, that's great, Alfonso. A few quick questions from the chat. For the non-crimp fabrics, would you use liquid resin such as RTM or vacuum RTM or resin film infusion?
They are most suitable to liquid resin infusion. And like I said, we're resin agnostic. You know, if you've just got room temperature stuff, it'll work. If you're capable to going to 250 or 350 F cure stuff, that's just as good. The resin system we use for our example was a standard 350 F cure epoxy, which infuses at about 100 C. So they're good for a variety of different infusion liquid resins.
Perfect. Well, thanks, Alfonso. I learned a lot as always, and thanks for coming on.
Thanks for having me. Really appreciate it.
For sure. We're going to switch over to Mr. Ted Thayer from Aglio now. Ted, over to you.
Hey, Sterling. Hello, everybody. My comms coming in all right?
Yeah, we got you loud and clear, sir.
Great. Let me know if anything goes awry. Hi, everyone. Good afternoon in the East Coast. It's still morning out here in California. My name is Ted Thayer, and I'm General Manager for Malio Inc., located in San Luis Obispo, California. First off, I'd like to say thank you to everyone who's joining us for this week's webinar, and especially to Colonel Diller, Sterling Alley, and the entire team at Agility Prime for organizing and hosting this tremendous event. We feel privileged and honored to be involved with the Agility Prime ecosystem, and we're looking forward to working within the orb building community in general. I'll also echo some of what Alfonso just discussed regarding using orbs to monitor fire danger in California. It's a very real thing for all of us out here, obviously. And I couldn't think of a better use for an orb network than to pre-spot with thermal imaging fires before they really spread. And, that would be, for so many out here, a worthwhile investment given what California spends on fire prevention as well as fire danger. So that said, I'll discuss Malio Inc. We fit into the Agility Prime ecosystem as.
Hey, Ted, I don't know if you were meant to be sharing your slides, but they are not.
Oh, I will. I'm going to stay on the slide, and I've got about 5 more. And so we'll slip back and forth here. Are you able to see this presentation currently?
Yeah, no, I think you just have to click share screen, Ted.
Aha, thought I had. How about now? Coming through all right?
Yeah, we got you now, sir. Thank you.
And how's the full size screen sharing?
Yeah, perfect.
Okay, good deal. But as I was saying, we foresee ourselves potentially fitting into the Agility Prime ecosystem as an orb builder, tier 2 parts and subsystems manufacturer. And we envision our level of involvement to be at the subsystems designer manufacturer level for either tier 1 orb builders or with other tier 2 subsystems builders, suppliers. I'll try to keep the following presentation short and concise while giving everyone an overview that describes how we may fit into the orb supplier ecosystem. And I'll begin with this basic Malio overview and then run through a general list of our capabilities and services before turning over to discussion to any questions. So Malio Inc. is a small privately held company that's been actively involved in UAV development for the past 16 years. The company's 2 founders were the lead engineers that developed the Desert Hawk UAV for the US Air Force. which was part of the FPAS program, and who've been the primary designers, engineers, and overall program managers for multiple UAV systems developed for Lockheed Martin and then sold to various US defense and intelligence agencies. For roughly the past 10 years, Mallywick has been developing payload systems, stabilized pan, tilt, camera, and tracking systems, UAV airframe and structural components, payload retractors, miscellaneous structural and control parts, ground station components, aircraft tracking antenna systems, various rail and handheld launch systems as well. Obviously, the demand now is for long-range VTOL systems, for which we're actively involved in making various parts, systems, and components. Mallywick is a subcontractor to contractors like Jennings Aeronautics and prime contractors like Lockheed Martin, specifically for their Stalker XE and Stalker XE VTOL programs. Our background in aeronautical and primarily mechanical engineering and design is diverse and yields complete in-house capabilities, generally found only in very large companies. We're a single source organization for advanced prototype development and short-run production, and we have complete in-house fabrication capabilities. We can manually mill and turn parts, CNC mill parts and molds, injection mold, unique and proprietary thermoplastics, FDM 3D print rapid prototype designs, do sheet metal forming, composite manufacturing, design and mold manufacturing. And we have experience in manufacturing techniques such as trapped rubber, rubber molding, as well as more conventional vacuum processes. Our in-house post-curing and vacuum capabilities assure high-quality composite parts with excellent mechanical properties. And in short, we provide all our customers with really practical manufacturing solutions in the shortest possible time while ensuring we stay within budgets. We are really a prototyping shop as much as anything else. And to be clear, I want to point out in this slide, we don't manufacture these UAVs, but we manufacture most of the control systems, hardware, various carbon fiber pieces, payload pieces, retractable payload pieces as well. And let's skip the next slide. So we specialize in engineering, prototyping, short-run production manufacturing. We machine aluminum, titanium, plastics, brass, steel, and virtually any other material with a full complement of Haas, mills, and lathes. We perform carbon fiber layup and composites. Other capabilities are assembly, electrical harnesses, industrial wiring, PCB soldering, mechanical bonding, fastening, other various composites, fiberglass, Kevlar, compression molding, trapped rubber, vacuum bag, casting, urethane, silicon, epoxy, finish work, laser cutting, engraving, machining, metal forming, 3 foot by 4 foot, 150-ton metal press, metal fab, routing, CNC, electrical and mechanical assembly, vacuum forming, deep draw capable, testing, inspection, and various systems analysis if need be. Some of our clients are listed on this slide as well. I'll close it by saying a little bit about Mallyo as a company. We've helped numerous customers over the years with various design, development, prototyping, and manufacturing projects. And we really hold ourselves to the highest possible standards in terms of communication with our customers, staying within budgetary constraints, delivering projects on time, and really, at the end of the day, ensuring all of our clients and customers' end product meets expectations, performs flawlessly, and is really the absolute best it can be. I think to wrap this up, we're looking to potentially work within the Agility Prime ecosystem as tier 2 manufacturer supplier for anyone that's looking for some of the capabilities that we have. And I'd be happy to discuss anyone's org project or design ideas to see if we may be a good fit for your needs. per the request from Sterling and the Agility Prime folks to address what some of the unique challenges we face are, I would say that for us, a routine challenge and that we and most engineering manufacturing firms usually face, whether it's in assessing, developing, or designing and building out a project, it's really in managing the inevitable project scope creep as the requirements and the capabilities morph and shift over time as a project takes shape. And obviously, staying within budget is always a very big concern, and we take that very seriously. And really, the key to successfully navigating this, as it is for most any company, is constant communication with the customer, updates with the client, and you all are probably very well aware how that goes. But in closing, I'll say thank you again to Colonel Diller, to Sterling Alley, to the entire AFWERX team, and to everybody that's attending this seminar on a Friday afternoon before the weekend. That's some real dedication, everyone. And again, my name is Ted Thayer. My contact info is on the slide, my email and phone number, and I invite everybody to, or anybody to reach out if you have any questions or want to explore some of our capabilities. And again, thanks for this opportunity. It's great to connect with everyone. It's a lot of fun. I'm really enjoying these webinars. They're really fascinating and enormously informational and educational. So thanks again to all of you. And at this point, I'll open it up to any discussions that you all may have. And if not, I'll hand it back to Sterling.
Yeah, for sure. Thanks, Ted. That was great. It looks like you guys have a ton of capabilities for those looking as a prototype shop and maybe even smaller part, large scale manufacturing. So appreciate that. Just for, I guess everyone's probably interested in this, but what kind of time frame usually does it take for you guys, depending on the part, from design received to initial manufacturing?
You know, it can take weeks and months. It's interesting. Right now, we're working with Lockheed's Missile Fire Control Group on a project that, you know, the ROM just came across maybe 3 weeks ago, rough order of magnitude. And we're trying to put a budget number on that right now. And parts have been shipping frantically from overseas, various motors and other components. And we're really trying to deliver this. Luckily, there's about a month reprieve, but within about 60 days time. And it's really a proof of concept project that is directly or UAV related. It's actually potentially for the US Navy is the one driving this project. And we, luckily, this project came to us while we weren't super impacted with other projects. And it's a really neat project that we're excited about. So we're able to really dive into it and devote our full attention to it. And it's really, candidly, in the engineering phase, those are the guys that really are feeling the pressure on this right now. But we can move pretty quickly. And we're lucky in that, being a small, kind of a dynamically sized company, we can move quickly and shift and allocate resources as necessary. But long story short, we plan to deliver this within 45 days, 60 days at the most. And then they'll be back and forth as that project morphs with other capabilities and requirements. So we can move pretty quickly. It kind of depends on what our current either backlog or client requirements are. We think it's going to be a really, really busy fall, but that's one of the first things we discuss with any potential client is what's the time frame, what can we do for you? And we try to make sure that everybody's completely aware of what our capabilities are in terms of matching their needs.
Yeah, for sure, most definitely. Well, thanks for coming on, Ted. Appreciate it. Always interesting to hear from you. I think now we're going to switch over to Chris Cusara from OneSky. Chris, over to you.
I'm here. Can you hear me?
Yeah, we got you loud and clear. Ted, if you could just stop sharing so Chris could share. There you go, Chris. Appreciate you, Ted.
All right, let's see. Okay, I think I'm sharing now.
Yeah, we got you, sir.
Great. Thanks for having me. Name's Chris Cusara. I'm with OneSky, new company founded by Analytical Graphics. I live near DC. co-founder of the company. We just started back in about December, but we've been at the UTM problem for about 5 years now. So UTM is a UAV or UAS traffic management system. I have a strong background in modeling simulation, having worked for analytical graphics for about 16 years and been involved in various aerospace and defense projects. And I'm also a commercial pilot. So that's the perspective I have on orbs and AAM and eVTOLs and UAM and all those different things. So what I wanted to talk to you about today is kind of I'd say about face from what we've had in the last two presentations, the hardware and really back towards Jeff and Atreus and what they're doing at the Autonomy Institute to help solve the infrastructure problem for AI. We're a little bit more focused on the actual, aviation sort of infrastructure, what needs to be done there to fly more routine flights, sort of beyond visual line of sight, especially for these AAM type vehicles. So I wanted to run you through my thoughts about the problem set and where I think the industry should head to support this kind of activity. So just a brief overview of our company. OneSky was spun out from AGI, a commercial software company, where we took a bunch of IP when we left, and we're developing UAS traffic management solutions. So the core software looks at modeling dynamic objects and understanding how a system of systems would function. So we can model things like satellites or aircraft and their performance along with anything in the environment that might cause an impact. So that could be interference from RF or weather situations, so that we can understand where it's safe to fly. You may have heard of a sister company of ours called Cesium. So they're handling a lot of the geospatial information. We use all their technology and help influence the development there. And then ComSpock is a space traffic management solution. So for about 10 years, we've been operating automated traffic management capabilities there and have brought them together to form our OneSky technology. So we really have a ground up and a space down solution, which is meeting with unmanned traffic management for aircraft. Assumptions that I have going into this presentation are just the UAM industry. Early flights will be manned using existing ATM infrastructure. So we're not taking that pilot out of the cockpit in the near term, and we're going to be flying in these corridors and increasing volume over time. As that volume increases, we need more automation, and that business model can't be realized without automation. And to get there, we need infrastructure. That infrastructure can come in the form of software like UAV traffic management to automate the tasks of ATM, UTM, and GCS integration. It also comes in the form of the things that Jeff was talking about, so the pins, putting that infrastructure where it needs to be to conduct the ComNav surveillance activity for AAM and UAM. This is a chart that I pulled from the FAA. This is showing you ADS-B and radar at different levels. So on the left, you have 500 feet coverage, and on the right, you have 3,000 feet. This is just from their website. So what this shows, though, is if you're flying at low levels, you're not going to have the coverage for what these systems were designed for. And if you get a chance to see Jeff's video on infrastructure, you can just go to his website. It's a great discussion of how do you get into a new domain and not expect to build infrastructure. So how do trains work without railroads? How does telecom work without telephone lines or cell towers? So as we wake up into the age of UAM, I think we need to understand that the existing ATM infrastructure can only take us so far, and we're going to have to pay attention to that and build new things as we need them. So one far out approach that we're thinking about is the Converge Tower. I've briefed this before at many different venues, but Converge Tower is leveraging industry infrastructure like cell towers, where we could deploy new technology, aviation surveillance like ADS-B or Wi-Fi, Bluetooth for remote identification, and then other things for environmental modeling like weather, acoustic monitoring, weather, acoustic sensors, or sensors that detect interference for maybe GPS interference. And then on board that, at the tower location, you could do edge processing, which allows you to remove latency and also only solve the problems that are relevant to your current area. That could help you with detect and avoid. It could help you monitor things that are going on, like obstacles that are nearby the tower, or provide corrections to GPS using things like RTK. So edge processing is the second thing about Converge Tower, which is of interest. And then the last one is, how do you bring concepts of UTM forward? So UTM it is located on the cloud, but if we pull those things forward as like micro UTM services, they can run in a more high performance fashion there at the tower. So Converge Tower is the long-term vision. I want to put that up front. What we do to enable this is look at the current infrastructure that's out there. This is a picture of Austin and just some hypothetical pin placement. And the pin is the device that Jeff was mentioning in the beginning to deploy infrastructure throughout a city. And then we can look at that planning over the urban environment and at multiple altitudes and show you where you have coverage and where you don't have coverage. So that allows you to both plan your flight, but also plan for additional capabilities if you want to fly somewhere and you don't have any CNS support. The way we do this is using our commercial software capability, Uas Toolkit, and this is showing you a communications example. First level analysis, we would look at just terrain and interaction. So how is terrain impacting your visibility from the air vehicle? So we can look at what infrastructure you have out there. It could be a point-to-point ground station supporting the flight, but then what is the terrain that's getting in the way? So this is showing you coverage at multiple altitudes. Second thing would be to bring in higher level of fidelity models to do comms analysis. So you can look at the RF parameters on board the vehicle and then at a ground station. And so we're looking at communication, carry to noise, power perhaps, and where could that be supported from the ground station to a flight in the region. And then you can apply that to the actual route. So you can see where you might have problems along the route and where you're probably good. These things can be then deployed in the operational system using what we call an SDSP, which is a supplemental data service provider. And you can consider this a black box, but what it does is it allows you to push in a flight plan or push in tracking data and get back metrics about how the system is supporting you or will support you on a future flight. An SDSP can be developed for communications, for surveillance, for navigation, for terrain interaction, for weather, and various different things, acoustics. So our approach here to the industry is to model things in advance and help people plan out their UAM environment and flights using our software, and then put them in the right format, these SDSPs, to enable their use in operations. So I1 Sky, I guess this is the sales pitch slide. We give modeling simulation solutions for the US and UAM industry. So we're modeling CNS, airspace, helping with airspace design. With our partnership with our cesium company, we understand ground data sets, GIS information, and how to integrate them into an operational solution. How those buildings impact things like acoustics or low-level weather. We've been in the game for about 30 years and have a lot of experience on the DoD side. And what we're developing now is specifically developed for the US industry. So what we're interested in is helping you investigate UAM infrastructure gaps. So how is CNS currently supporting your activity? Where might you have problems, and how can you fill in those gaps with new technology or new ways of doing what you're trying to do? And finally, as you get towards operations, which is hopefully is in the near future, helping to provide operational solutions like UTM services. And so doing that in the near term and the long term. So with that, I appreciate the time and ability to give you my perspective here, and I'll hand it back to Sterling.
Yeah, thanks, Chris. That was very interesting. One of the questions from the audience that was actually right in line with what I was going to ask is, what cities do you need more data on? Do you guys use kind of like LiDAR drones to get your geospatial data? And then what kind of validation or regressing testing do you do to prove out your predictive models?
Yeah, that's good questions, kind of two different things there. The first one, I'll address the second question first, regression testing. So, I mean, being able to do this for 30 years, we have a lot of regression testing on our software. So the core software has gone under regression testing on every version. Did some initial work with the Aerospace Corporation that helped us validate our software, and we do regression testing against that. So the second question was about, I'm sorry, can you repeat that question?
Yeah, just kind of like, I guess, the timeline for acquiring data on cities, what methods you guys use.
So initially, I think that there's strategic data that you have, and this is really just more for planning. Data is a problem. So if you look at, FA data sets, you have towers at 200 feet and above, and things below that altitude are really, unknown. You can go out and capture data, but as soon as you capture it, the data becomes stale because things like cranes can move around. The only time you need to report a crane is if it's near an airport or if it's over 200 feet. So unfortunately, those things, cranes, kites, whatever it is in between, could get in the way, and those become issues. So you have to have something on board, probably to provide a secondary layer of defense. So we'll supply a strategic layer of defense with the data that we have. We have good data sets for buildings and for terrain and for obstacles that are known. But for those things outside of that, we need to have other onboard systems to help.
I'm sure. I think that's very interesting. Thanks for coming on, and lovely to hear from you guys as always. So switch over to our last but not least speaker, Chip Downing from RTI. Chip, over to you.
Thanks, Sterling and Colonel Diller, for inviting us today. Happy to be here. Let me share my screen with you. Can you stop sharing?
I think I need to do that. Let me figure out how to do that. I'm sorry. To find my apologies. There we go. Okay.
Okay, now we're talking here. Can everybody see that screen?
Yeah, we got you, Chris. If you could just go full screen. Yeah, perfect. Thank you, sir.
Okay, great. So I'm Chip Downing. I'm the Senior Market Development Director of Aerospace and Defense at Real Time Innovations. I manage our global aerospace and defense business. I'm also chair of the Future Airborne Capability Environment called FACE outreach team. That's a government, industry, academia consortia to build reliable and rapid time to market avionics platform for military aircraft. We're for Real Time Innovations. We're certainly a leading connectivity framework for autonomous systems. We have over 1,500 commercial design wins. We have dominant what's called data distribution service market share, and I'll talk about that in a few more minutes. We've formed over 20 years ago, and now I've got over $40 million in annual revenue and growing about 25%, mainly due to this big autonomy push. We've got headquarters in Silicon Valley and Sunnyvale, California, and also worldwide offices. We're a leader in global standards. We're the first to market with this DDS security standard. We also have got the first RTCA DO178C DALA certification evidence for a product. And we're also the first certified conformant FACE transport services segment contribution. We are in a lot of standards like AUTOSAR, ROS, FACE, NATO ground vehicle or generic vehicle architecture, UAS, SOSA. So we're well aligned with all these different types of standards. We, as I mentioned before, we're very strong on autonomous. We have over 250 autonomous vehicle programs we're now working in, lots of passenger vehicles, air vehicles, UAMs, There's over 100 defense systems that we really can't talk about, also things like Hyperloop, so, and quite a few research programs. What the product we sell is based upon the Data Distribution Service Standard. It's managed by the OMG, the Object Management Group. We have over 12 different implementations worldwide, so we're not the sole source on this. It comes in 3 parts. The top part is just a DDS API. This is what application programmers write to. The bottom side is a wire protocol, so everybody's exchanging the same type of information over the wire. And then we have a DDS security plugin. So after you have your system working, you can then add different types of DDS security and secure that down to the data elements. So you're gonna have different pieces of data being secured by different authentication and encryption capabilities. The DDS Secure, is based on the security standard. We have these built-in plugins that are ready to go. Runs over top of any transport. You don't have to have a special transport to go do this. It's completely decentralized, just like DDS. It's peer-to-peer. And there's, once again, you can add different agencies and different companies can add their own encryption and authentication for data being contributed to the UAM network. We have authentication, access control, cryptography, data tagging, and logging with the security standard, and you can bring in your own type of encryption and other capabilities as required. How does this work? Essentially, there's different nodes on it, some type of network. We call it a data bus where they all share information. So you could have thousands of entities sharing the same types of data. You do both publish and subscribe. And then you can also, from an application standpoint, we take care of all the message formats and the caching, the quality of service, the reliability, socket program. We do all that for you. All you do is write to an API. It figures out what the network is underneath it and then provides that data to other entities on the data bus. If you need to bring in different types of data, you can then bring that in. We have a routing service to go from different types of data or different formats of data. So you can actually connect up a wide range of systems without re-architecting your platform. Really key here is it's peer-to-peer. There's no brokers, there's no servers involved. You just have entities that exchange information in a publish subscribe format. It's loosely coupled, so you can add and delete, upgrade capabilities very easily. It's got discovery capabilities, so as you add new entities onto the networks, it does an auto discovery and starts publishing and or subscribing. I mentioned before, it's got a real-time quality of service by design because it's peer-to-peer. It's inherently parallel, so it enables massive scalability, and we've proven this on many, many platforms. Some actually have over 10 million entities communicating. And of course, it's all standards-based. We have 3 products. It's called DDS Professional. That's our full product with all of our capabilities. We also have got DDS Secure that layers on top of that. It provides the security capabilities I just talked about. We also have got DDS Micro, and that's really for microcontroller environments. And then DDS Cert, that's the certified platform I'll talk about in a few more slides. As I mentioned about scalability, I think one of the coolest examples at the NASA Kennedy Space Center Launch Control. There's over 300,000 entities communicating at 400,000 messages a second on the final minute before launch. And it's fully autonomous. There's no longer some engineer inside a space center with a finger ready to hit a button. All these launches are now fully autonomous. And we also participate in other aspects of the launch as recovery and communications. We have a new product called Connect Drive. It's very powerful. It actually is based upon DDS and enables ROS, ROS2, and AUTOSAR to then be quickly used inside of our environment. If you know anything about ROS2 or Robot Operating System 2, it's actually based upon DDS, the standard, and we enable that and then bring in other capabilities. What this looks like is we have our Connect Drive data bus. We then can bring in ROS2, Adaptive AUTOSAR, AUTOSAR Classic, and then bring in any type of next generation architectures as required, whether it's for autonomy, for teleoperations, any type of communications capabilities, you can now bring that into this environment. What this ends up being is a very interesting sensor to cloud capability where you can actually have the in-vehicle platform. And this is where you have all your sensors, your radars, your AI all communicating on a data bus inside the car. And you can do vehicle-to-vehicle communication and vehicle to other types of communications, like the what was that called? The tsunami of technology blight. You can bring in that type of information from there. You can then do fleet management. How are you actually going to manage these fleets? What happens when things stop? You can then do teleoperations from there. And then you can start to monetize that information that you're building out in the ecosystem with information up in the cloud. Really interesting project we're working on right now is what's called the India Autonomous Challenge. This is where we're actually having over 30 teams, over 500 students, over 35 universities race autonomous cars, no drivers cars around the Indianapolis 500 racetrack. It's going for level 4 autonomy. These cars will be going around 200 miles an hour. They're doing this virtually using the ANSYS design tools. You can actually do all your design and code generation using the ANSYS tools, and we're actually going to have virtual races until next year. Next October in 2021 will be the final race for this India Autonomous Challenge. It should be pretty exciting. We're also part of the Varen Vehicle Skyscraper project, and they're also part of AFWERX. Varen Vehicles and the Skyscraper project is looking to put vertiports around some of the major cities in Colombia that have very dense populations, but very small spaces. Congestion with automobiles is amazing. It's one of the most congested cities in the world. So they actually want to have vertiports move both equipment and people around the city and expect to build up whole communities around these vertiports. So it's an interesting project to watch if you're not part of that now. We also, as I mentioned before, we're part of FACE. FACE is a Future Airborne Capability Environment. It's a layered architecture based upon segments, and starts at the top with the portable component segment, which is the applications. We also have the transport services segment. Underneath that, there's platform-specific services segment. That's actually what's in the vehicle, what type of capabilities are there. The I/O service segment is really drivers for the hardware, and then of course you have an operating system of any choice, and then lots of different types of hardware. So what this looks like using a FACE diagram is you can see the operating system segment on the left-hand side, transport services segment that RTI contributes to on the right-hand side, and then you can have applications at the top. And this is a specific application, but it comes from a large defense contractor. You've got Core AVI certified graphics. You have Army capabilities built in there. You have pre-SAGES design tools for HMIs, and then you can have other capabilities throughout the system. We have been working with FACE. I personally have been working with FACE for over 10 years. RTI is the first company to get what's called certified conformant FACE transport services segment back in 2018, and we'll have the latest version of FACE, looks like 3.1 in Q4 this year. One of the most powerful parts of our product is our COTS DO178C DAL-A certification evidence. This is a complete package of certification evidence that you can give to your FAA examiner or anybody else going to review your platform. And it's ready to go as far as the RTI, either DDS and or TSS components. We're going to certify both. So my main message is this one right here. We have a strong ecosystem of microprocessors that can be used inside these orbs. We have a very good partner operating system that have certification evidence ready to go. There's no investment required. We've got our DS rides on top of that. All you have to do is write your innovation on top of this platform, and you're ready to go. The platform itself will be certified at the highest level of DAL-A, but your applications do not need to be certified at that level. So it's very powerful. We can actually have different levels of safety criticality on top of your compute platforms. And that's it. If you want to communicate with me personally, you can just send me an email, chip@rti.com. Best email I've ever had. Otherwise, you can take a look at our website and or Facebook, blogs, podcasts. There's lots of information on the website.
Yeah, for sure. Thanks, Chip. That's great. Great to hear from you, and super interesting stuff you have there. Let's see, maybe one question from the audience here. Yeah, so from Bill, are you synchronizing with the Navy and DoD on cybersecurity architecture that, among many things, can let you distribute functions through DevOps?
Yes, so we do absolutely synchronize the Navy. We're part of the Navy open architecture. We're in every modern Navy surface ship. And also, if you take a look at the radars on the different naval ships, different defense platforms, we're in all of that. So that most Navy ships today use our DDS to do the communications between the different data centers, defenses, and missiles and other type of offensive weapons.
Yeah, for sure. Thanks, Chip. Great to have you on. And I think now we're going to switch over to the last 15 minutes to Captain Uas from the AFWERX division, speaking on STPA. Captain Uas, are you there?
I sure am. All right, let me share my screen real quick. Maybe it's telling me. Actually, Sterling, can you push the slides? I'm getting a weird error with Zoom here.
Yeah, sure. Just 1 second here. Let me get them up.
Okay.
Yeah, if you want to go ahead and introduce yourself and kind of you're here, I'll get the slides going.
Okay, perfect. Hi, so I am Captain Matthew Oust. I am one of the cybersecurity analysts that works for AFWERX, which is the Air Force Operational Test and Evaluation Center. So anytime the Air Force buys a new toy, we are the independent organization that does operational tests. We take it out in the field, drag it through the mud, and make sure it actually works. My super fun job with all that is I get to be the guy that tests the cyber side of things. So today I want to talk to you about a systems engineering approach to doing both cyber test design, but also for designing in or designing a system that is secure from a cyber perspective, but also from a safety and a functional perspective. So it's called System Theoretic Process Analysis. If you go to the next slide. All right. So essentially this process that we're using, like I said, it's a systems engineering approach. And really it was born out of necessity. I'm sure you guys are familiar with a lot of the more traditional types of hazard analyses, such as FMEA and FTA, FMICA, HAZOP. But a lot of these were developed before we really had highly complex software intensive systems. And they were mostly reliability based. And this works really well for electromechanical systems that don't have complex software. And even more than that, they work well when you don't have humans involved. Because if we've learned anything in the existence of humans, it's how complex our thinking is and sometimes irrational. So a lot of the reason why STPA was created was from Dr. Levison at MIT studying accidents. And so the Challenger incident, chemical treatment facility accidents, nuclear accidents. And what she found is that many of these accidents don't occur because of a single component failure. A lot of it is because of the system behavior. So nothing broke per se, but the system behaved in a way that was unanticipated. All right, so we can go to the next slide. So we needed something new. when you're looking at reliability engineering, so your more traditional hazard analyses, a lot of them are trying to solve the problem of how do we eliminate or reduce unsafe scenarios that are caused by a trigger. And even the Air Force is doing this with our criticality analyses that we do of which component in the missile or which components in the airframe, if those go down, then everything breaks. And the problem with that is when you look at reliability engineering by itself, it doesn't cover scenarios that aren't triggered by a specific failure. So if you can see in this little chart here, you have scenarios that are triggered by failure that the system catches. So these are those safe scenarios. Something goes wrong, but we designed the system well and it caught it. Okay, cool, good deal. And then we have unsafe scenarios that are triggered by a failure. Okay, cool. That means we saw something bad, but it's a failure and we know how to solve for that. But then we have these scenarios where there was no failure. The system designed exactly how, or the system behaved exactly how it was designed, but the designers didn't take into account the interaction between the components and that resulting system behavior. So this is where we have either system design or a combination of system design and component failure that leads to accidents. And the goal of STPA is we want to try to control that system behavior through systems engineering to prevent accidents from happening. All right, next slide. So how do we do that? How do we handle complex systems? Anyone who has dealt with code or looked at modern computers, billions of lines of code. And especially if you look at an i9 processor, you can zoom in to the size of a pinprick, and that pinprick takes 50 to 100 people to understand how that one little piece works. So imagine we have a F-22. There is no way that we can sufficiently decompose that and understand all of that functionality. And even more so, how does the avionics of the F-22 interact with the fire control system? How does that interact with the pilot? How does that interact with the communication system? These systems have become too complex for us to easily understand. So you can see on this chart here, our degree of randomness versus the degree of coupling. So basically, how much random activity can occur, or you could better state that as the indeterminate activity that can occur in a system. So rather than deterministic, it is indeterminate. It could be A, it could be B, it could be Z, we don't know. And when you compare that to the degree of coupling, so that's what I was saying before, the avionics interacting with flight control, or not flight control, with fire control, with communications, how much are those coupled together where one system affects the other? And what we find is the traditional method of decompositions, that analytical reduction. Let me break it down and just look at fire control. All right, now I'll just look at communications. It works so long as those subsystems are independent. We don't have, or we only have linear interactions, and that the components act the same when they're examined individually, and that they act the same as when they're part of the whole. And this works really well when we have a low amount of randomness or indeterminability and a low amount of coupling. But as you look at increased randomness and increased coupling, we have this complexity that cannot be handled by that. And that's where systems theory comes into play, because it is a top-down approach that focuses on the component interactions and is able to capture how, when I'm trying to fire off a AIM-9X, how does that affect my communications, affect my flight control? I look at all of that as the system. Okay, next slide. So what is STPA? In short, it is a systems engineering approach to investigate the mishap or the accident before it happens. And what we do is we start with the high level. What are the accidents we're trying to avoid? What are these hazards that can lead us there? We model the system at a functional level. What are the functions the system has to accomplish, rather than looking at how does it do that? What are the computers and the servers and the physical parts that does that? We look at functionality. What does it do? And from there, we can see where can that go wrong? And if we know where it can go wrong, then I can develop scenarios of why this unsafe action may occur. I can hypothesize these accidents before they ever occur. And this covers, empirically, has covered everything that FAMICA, FAMIA, HAZOP, FTA, all the other approaches. STPA finds all of the same things and more. So we can do everything we could before, and now we start finding edge cases that the designers never thought of. And we design that out before you end up with an accident. Next slide. So the question is, how are we using this with Agility Prime? Yep, you're right. Next slide. You're good. And the answer is threefold. So first and foremost, we are using this as the foundation for our military utility testing. So any prototype that that we think may be useful for military testing, and we get to that point, this is how we are going to test your system. We're going to analyze it. We're going to develop our test cases, and this is how we will. This is our measuring stick of, can it meet our needed functionality. But even more so, we're planning on sharing everything we do with our partners. And what this means is STPA, which is part of DO 356 Alpha Appendix G, can satisfy the DO 326 airworthiness security process requirement for FAA certification. Next slide. So where we're at right now is we have done an initial sprint, and we have generated a model of a generic eVTOL. And we have looked at what are the accidents that can occur. We looked at functionality-wise, what does every eVTOL have to have, regardless of how the specifics of that platform, and then where can that go wrong? And what we plan on doing once we finish kind of dotting the I's and crossing the T's is using this or inviting our industry partners to work with us. We want to share this with you, show you what we have, and then extend our baseline with your specific platform. And then everything we come up with, it's yours to keep. And if you want to take that and run with it as part of your airworthiness for security certification, that's yours. And we have contacts within MIT that are excellent at facilitating, and we can put you in touch with the right people if you really want to take this and run with it. But really, we can help you find both functional and cyber problems before they ever exist and help you design those out. I think I'm out of time, so I'm going to end it there. Any questions?
No, that was great, Chris and Captain Ost. I really appreciate you coming on, and hopefully the folks out there in the audience learned a lot from that today. So I appreciate you coming on. I'm looking forward to seeing the process as it starts putting some orbs through their paces. Absolutely. And if anyone in the audience wants to get a hold of me, you can either find me on the Air Force Global or on LinkedIn. Last name is AUST, first name Matthew.
feel free to find me, and I can answer any questions, put you in contact with anyone you need to.
Yeah, for sure. Thank you, Captain. And thank you for the audience. Thank you for joining us today. We will see you again next week. Everyone have a great weekend.